Last week, I did a thing on networking, and after it, there was a couple of wee things came up, one of which I'll just tell you about, because it only takes a minute. The other one I made a wee PowerPoint presentation on because there's 2 or 3 different details to it. The simple one is this. Somebody asked, if you've got DHCP set up on your machines round about the house, your computers, your laptops or whatever, and for some reason your DHCP server is down, your router's off, what happens? Does the machines then just not get a network address? Can they not work? And it turns out that Microsoft have put a thing called Automatic Private IP Addressing, APIPA, which if the machine is set to DHCP and it can't find the DHCP address, then what it does is it gives itself an IP address in the range 169.254.something. And the reason it does it is that means that private address, all your machines that wake up without being able to speak to DHCP will be able to speak to each other. And so your network will still work. They might not be able to get out, but they'll still be able to speak to each other because of this default addressing. And it's also a thing that we use when we're figuring out, when I nearly said buggering about with, when we're working hard with networked computers. If you look at the IP address using the IP config command and it's 169.254.anything, you go, there we go, the DHCP is not working. And that's the way to tell that DHCP is not working. It's switched on but not working, is because it's switched on and you get a 169.254 number. So that was the simple one. I will now share my screen. The second query that came in was a person that was convinced that there was somebody in their machine. How do they know who's connected to their machine, who their machine's connected to, and what's going on? Is there anything being exfiltrated from my machine? How would I know about that? You know, I kind of left this one alone because I was thinking that maybe further down the road, I might talk some Sunday about troubleshooting the networks. But this seemed so simple. It's one command that it's probably worth doing just as a simple 5-minute chat here. There's a command that's on all machines, all PCs, Windows, Linux, Macs, everything, called Netstat. It can mean network statistics or it means network status. I have no idea. I've heard both used. You can get it from anywhere. You run it from a command line, from a black screen. But some of the commands that are involved inside it means that you have to have admin elevation. Now here we go. Can you see my mouse? Down there, you type CMD. Up here, it offers you the command prompt. But before you just click on command prompt, you right mouse it and tell it to run as administrator. And this is a good trick to learn for a lot of things. That if you right mouse, you can always run them as administrator, and you get slightly higher privileges. There's Netstat. Now, if I run Netstat without any connections, there what comes up. Now, I've just told you another one of my famous lies, because actually, if you do run it without a network connection, you'll still get a load of garbage in there. But I put that up so that you can see what the headings are. The protocol being used, the local address, that's the address on my machine. The foreign address, that's the address at the other side of the network. And the state of it, is it active? Is it waiting for a command? Is it, what kind of state is this connection in? So if I do a naked call, this is what I get. This machine is 192.168.1.192. It is also 127.0.0.1. Every machine, the local 127.0.0.1 means this machine. the machine I'm on, irrespective of what this address is, that always speaks back to here. So there's the local addresses. Those there are simply IP6 versions of the local address, IPv6 versions of the local address. The foreign address, now this machine happens to be called M4800 because it's a Dell M4800 laptop. And so on that connection there, the machine is talking back to itself. So these are internal connections being made via the TCP/IP stack. Now the TCP/IP stack is used to connect to networks, but it's also used to connect internally between programs on the machine. When I pressed the button and made this happen, it took nearly a minute to appear, because as these things appear, every one of them causes a DNS request, the domain name service request. So it asks who is whatever that number was, and it get back, oh, it's 1HR48S or whatever, and that HTTPS is port number 443 and all that groovy stuff, and it has to do that work. So in order to not use the DNS, if I simply give it netstat -n, then the command runs instantly. And there's the same command run, only this time netstat -n. There's the connections. You see these, a lot of these are from one port to another port. And then there's the connections from my machine to other machines. Some of these are established, some of them are closed and waiting, some of them are timed and waiting. Yep. 443, that's an HTTPS, that's a secure hypertext protocol, secure web page. Wonder what it is. Netstat -a says netstat, but give me all. I don't just want the information about the active ports, give me ports that are just quietly getting on with it. At this point, I have to take a smaller picture because there's much more data in it. And there's lots and lots of ports that are just quietly listening. And that tells me every port on my machine which is open, which is accessible from the outside world, from the planet. This is the groovy one, netstat -b for binary. And that says, show me the details as before, but show me what binary is causing this to happen. So there's Google Drive.exe. So that must be a Google machine. There's Firefox talking back to itself. There's WPN service, which I had to go and look up. SVC host, that's the Microsoft Intelligent Transfer. I had to go and look that one up, talking back to, do you need any updates? More Firefox, more Google Drives, and I can see what program is talking to what machine in the world via this B switch. And then F is fully qualified domain name. So instead of just the name of the domain already, give me the fully qualified name of the domain. So here we have that there is actually US West 2 compute unit at Amazon AWS. That's a CloudFront at Google. There's a Google user content page. That'll be my G drive probably. And so I can find out exactly what machines I'm connected to. And these switches can be combined. So if I do BAF or FAB, which is the ones that I use an awful lot, then that means F, I want the fully qualified domain name. A, I want all the information for all the connections. And B, I want to know what binary is causing it. Well, there's just FB, because if I do FAB, it's pages and pages and pages of stuff, because there's now twice as many lines. But here we have there's a TCP connection on my machine from something called kiteed.exe, and it's going to that Google user content page. And it's an established connection, and it's passing information. And my Google Drive is currently talking to that there on Google as well. And so it goes on. Lastly, Netstat minus fab is all you really need to remember. But there's also Netstat minus question mark, which is help. And that'll give you all the information for all the stuff that I've just explained, plus other stuff that I haven't explained, what protocol I'm using, how to show me Ethernet statistics, show me the amount of data load to and from the target, stuff like that. There's all sorts of groovy stuff in Netstat. There's a couple of other tools you should also know about. If you're using Netstat, then you've got these things available as well. NSLOOKUP will look up the name server. Here's an IP address. Who is that? And you can look it up. Who is does the opposite. You can say, here's the name. What's their IP address? There we go. I decided to look up merg.org.uk, and local LAN server came back and said, it looks like the answer is 185.146.20.64. So at that point I said, okay, who is 185.146.20.164? And it came back with, yeah, that's merg.org.uk, right enough. And here's when it was registered and who it was registered by and when it's to be paid for again and all that groovy stuff about that user. The other thing you might want to do is this. If I change directory to the root of a machine, that's me now at the root, I can do dir/s. /s means including subdirectories. And remember that binary kiteed? I had no idea what kiteed was. So I went to the root directory in my machine and said dir/s kiteed.exe, and within a few seconds it said, yeah, C drive program files kite has got a program in it called kiteed.exe, and there's only one file in the whole of your PC that's got that name. So I now know if I wanted to stop that, I could just go in there and delete it. Now, just for completeness' sake, kiteed is the program when you're typing into your Arduino or into an editor and it fills in, you start typing a word and it fills in the rest of it for you, the intelligent completion stuff, auto IntelliSense, stuff like that. That's a private version of that you use for certain programs like Arduinos and like Python and so on. And that's me done. Questions or worries?